today we'll start Newton laws of motion. Okay? So this chapter is the classical physics under the classical physics, okay? And it is the base of the mechanics. So we'll have to carefully cover this chapter. First, in the previous chapter, we have discussed like what is motion, rest, light velocity, speed. So it's all the effect like both of the use of after the results. So in this chapter, now it's what is the cause because of the result which we are getting. Okay, okay, the first हम लोग को जानना होता है force. What is force? So you can see the definition. Force is a physical quantity which can change the state of motion or can try to change the state of motion of an object. So force, if we apply force any object, it can change the state of the object. Like if some object is in running, moving in a same speed or velocity, then if we apply force, it states like it is in motion, it can be rest, or some object in rest. If we apply force, it can be motion. So force try to change the physical quantity of the body. There is many forces we will now, but in this chapter we'll mainly focus the contact forces. There we see some forces are there, like gravitational force, weak force. Weak forces is like is compared with nuclear force, electromagnetic force, and nuclear force is there. So that we will discuss first. We cover the whole the Newton laws. So what is Newton first law of motion? Newton first law of motion said that the state of motion of an object does not change until and unless external unbalanced force is applied on that body. This is also called law of inertia. So I think you don't know about inertia. Inertia is like frame. If you see any object, there is some ground frame or some like perspective. If we see any object, there will be some position or perspective. For that, the body will see some results. So what is Newton first law of motion said? Newton first law of motion said that if it doesn't apply any force, okay, so the body is always in motion, then the body will be always in same speed or same velocity moving in the same direction. There will be no changes. If their external force is zero. Also, if some object in this, then it will be it will be always in rest because the external force is zero. So the external if we see some example that that both sides like both the side that is applying same forces, then if external equal to zero, then also the body will be not move. Like so now Newton's second law of motion, what is it? It is if an external unbalanced force is applied on a body, then the acceleration produced on that body is directly proportional to the applied force and inversely proportional to the mass of the body. So it's said that the force applied on the body, it will be proportional to the acceleration of the body and the mass will be inversely proportional to the acceleration. Okay. We'll say like A proportional to F and A inversely proportional to 1 by F. So from that we can conclude F equal to M. Okay. And also another way we can discuss Newton's second law. What is it? It is said that rate of change of momentum is equal to F applied, force applied. The rate of change of momentum with respect to time gives the applied force. So from that we can write the rate of change F equal to ma. A we can write dv by dt. Then F equal to dmb by dt. F equal to dq by dt. That is the rate of change of momentum. Okay. Next we see some example like say the particles p equal to the particle if momentum of particle changes as p equal to 3t square plus 40, then find force at t equal to 5 seconds. So we have to find the force at t equal to 5 seconds and that's particle momentum changes p equal to 30 square. So we apply dp equal to dt equal to 3. So now difference. What will be there? 60 plus 4. Now we apply t equal to 5 seconds. So what will be the result? 34. That is the force at t equal to 5 seconds. And now third law. Newton's third law we always heard that we were, like, already know what is Newton's third law. Every action has equal and opposite reaction. If we like we are in the earth, so हम लोग अभी अर्थ पे बैठे हुए हैं खड़े हुए हैं, ठीक है. We are also applying like gravitation force is applied on us. That's but we also applied some normal in the earth because like gravitation force is mm, applied on us and also one normal is applied. That's why we are like it is n equal to mg. mm, Opposite every reaction is equal and opposite reaction. And the one more thing that Newton's third law, the force will apply in different objects and the force will be equal and opposite. Okay. So now we see like how to apply Newton's second law of motion. So there are some steps we have to remember. Okay, before applying Newton's second law. What first step? We have to select a system having same acceleration in same direction. Okay, the acceleration and the direction will be same with the object. Second, identify the forces. Identify the forces means all the forces acted on the body. Okay, we'll see what is how we can identify the forces. Otherwise, and draw a free body diagram. So we'll discuss what is free body diagram and then we can apply second law. So what is free body diagram? Free body diagram is a diagram where we show the all the forces applied on the body or body applied other body the forces. Three things we have to remember when we apply. We draw FPD. First one is we have to all the objects or particles will be can be taken as a point mass and we have to show all the forces applied by the body. All the forces acted on the body, like not applied. All the forces are acted on the body. Third one is we have to select one frame of frame ground. Like most of the cases that is ground field. Some cases we have to take a pseudo force like that. We apply pseudo force. We'll see discuss later. So here is some example. Uh, what is first one? System having same acceleration direction. There is no acceleration with no. Then there is FBT period diagram. Like we draw that is FBT period diagram. Okay. Ma- Mass mg and so you can write n minus mg equal to m into 0. Now apply Newton's second law. F equal to m. N minus mg equal to m into 0. So now write n equal to m. In the next example, you can see that find how to find normal and acceleration. Okay. So it is there is no friction. It is a smooth surface. The body of the mass of the body is 2 kg. There is no force applied 20 Newton at a theta degree. Okay. So we'll take component of the force. One is F sin theta and F cos theta. And there is a downward mg and upward n. So now that it is already discussed that it is in equilibrium. So now equal all the forces. Okay. So n plus F sin theta minus mg equal to m into 0. So n plus F sin theta equal to mg. Next one n equal to mg minus F sin theta. N equal to 2 into 10 minus 20 by half. So 20 minus 10 equal to 10. Along x-axis, x-axis f cos theta equal to mass into f cos 30. 30 is root 3 by 2. F, F values is 20. 2 10 root 3 by 2 equal to a. Equal to 5 root 3 meter per second. Okay. We have find the acceleration and the normal. Here is one more example. This is also same like this is applied in 30-degree angle, there is force applied on a angle of 30 degree to the body. So like we draw the FBD, then we apply the same things.